Hello everyone, welcome to this video. In this video, we shall be looking at another question from IIT-JAM 2022 consisting of 2 marks, and this is an MCQ type of question. So that means only one option would be the correct option here. So the question here, it is asking you that what is the area of the image T of G of the map T. So here you are given some map T, the function T, which is defined on 2 independent variables S and T. So that means your given domain that is represented by G is something of a rectangle. So let me draw it somewhere here. So if you see this thing, if you have this as your T axis, this as your S axis, right? This is the origin here. So suppose this is 1 unit from here, this is also 1 unit from here. So you have something which is in fact it is a square, right? All the sides they are equal, right? So here the given domain G, that is a sphere, and it does not include this boundary. This boundary is not included here. Fine. So now we are required to calculate that what is the area which now onto whole of this area we are applying the mapping T, and we are looking at some points here in another domain. Say this is M1 axis, this is M2 axis, right? So here on this M1, M2 axis, after applying this mapping T onto whole of this space, what would be the area here? We actually don't know exactly what is the shape as it is. So we are required to calculate what is this T of G, right? What is the area of this image T of G? So now let me first of all again write down the mapping T of ST, that is given to be pi s 1 minus t divided by 2, right? And pi 1 minus s divided by 2. So this is the mapping that is given to us. Now I am showing you 2 methods to solve this question. So let's proceed on to the first method. Now because we are required to calculate this area, this T of G, so that means we are to calculate the double integral, right, of dm1 dm2. In order to calculate this area, we'll take some small portion here which is some rectangle, right? And for this rectangle, we'll be integrating firstly on this side and then on this side. So your formula would be, firstly you will be integrating with respect to M1, and then you will be integrating with respect to M2. This is what we are to find. We are to find, right? Now this thing is, if you have studied about the formulas here, this thing is nothing but it is equal to, now we can shift these image mapping, so this image areas to the area of the domain using the relation that we just have to multiply by the Jacobian of the dependent variables with respect to the independent variables. So the Jacobian here, and d of s, d of t. So this is same as this thing. So these two things, they are same. So we'll calculate this thing because, why? Because we know what is the area of this domain G. We know what are the limits for the independent variable S. We know what are the limits for the independent variable T. So we just have to calculate this Jacobian here. So for calculating the Jacobian, what we are doing, we are calculating the partial derivative of the images. So that means M1 and M2 with respect to S and T, right? So this is what we are doing. So it would be the determinant of del M1 by del S, del M1 by del T, then del M2 by del S, and del M2 by del T, right? So this is what we have to calculate here. For doing that, first of all, we have to calculate the partial derivatives here. So if you see what would be the partial derivative, so what is this? This is your M1, this is your M2. So let me write down the functions here again. Your M1, that is equal to this function pi s 1 minus t, pi s 1 minus t divided by 2, and your M2, that is given to be pi 1 minus s by 2. So let me write down pi 1 minus s divided by 2. Now we have to calculate what is del M1 by del s. So it would be, the partial derivative would be pi 1 minus t by 2. So how do you differentiate partially? You just keep this one as variable and all others as fixed, right? So this is what we have. Then del m2 by del s, so it would be equal to minus pi by 2, right? And then del m1 by del t, so with respect to t, what is the derivative here? So it would be minus pi s by 2, right? And del m2 by del t, so it is equal to 0. So when you calculate the Jacobian here, the Jacobian, that would be equal to del m1 by del s, so let me write down here, del m1 by del s, that is pi 1 minus t by 2, right? And then del m1 by del t, that is minus pi s by 2, then del m2 by del s, that is minus pi by 2, and then 0. So when you calculate this thing, the Jacobian, you would have 0 here, 0 minus of minus pi s by 2 multiplied with minus pi by 2. So when you solve this, you have minus pi square by 4 into s. So this is the value of the Jacobian. Now once you have this Jacobian, let's substitute it here. So the area of the image, that is what? That was your integration of the small element dm1 and dm2. This is nothing but equal to the double integration of the Jacobian function and ds dt, right? Now you have calculated the Jacobian function, that is minus pi square by 4 times s ds and dt. And now you just have to look at the limits. For limits, we just have to again draw the domain area. This is your s, this is your t. On the s axis, we have the area, which is a square. Overall, the area is a square, right? This one. So when you take out the limits here, the limits would be from 0 to 1 only. 0 to 1 and 0 to 1, right? So this is equal to minus pi square by 4 s square by 2, and when you substitute the limits here, 0 to 1 dt, and solve it, let's see what do we have. Minus pi square by 4 as such, in fact minus pi square by 8. The when you substitute the limits, you have 1 square minus 0 square, and then dt, 0 to 1. And when you solve this thing, you will be having minus pi square by 8 as the answer. And because we are taking the modulus value, this thing would become plus here, right? So obviously the area is a positive quantity, that is the absolute quantity. So your answer would be pi square by 8. So let's look at our options here. The options here tells us that C is the correct option. Now let's move forward and look at the second method for solving this question. So method number 2. This is not any formal method, but we can think to solve this question in this way also. For this, what we are looking at our domain. So this is s axis, this is t axis, this is 1, this is also 1, and this is your square, right? This is the point 0. Now here we have to look that when we apply the mapping t onto this, what kind of area do we have here? So how can we look at this thing? What is this point? This is 0 and 0. This point is 1, 0. This point is 0, 1. And this point is 1 and 1. So what we do here instead is we look at the image of the corner points here of the domain G. This is your domain G. So what would be t 0 and 0? What would be t 0 and 1? What would be t 1 and 0? And what would be t 1 and 1? So this is what we are solving here. So when you substitute all these quantities in the definition for t here, this one, let's see what do we have. When t and s both are 0, we have this as 0 and this thing as pi by 2. So for the first entry, we have 0 and pi by 2 here. For the second entry, what do we have here? When you substitute s as 0, t as 1. Let's see here. When you substitute s as 0, this first entry is 0, and when you substitute s as 0 here, this thing would be equal to pi by 2. Again, we are getting the point 0 and pi by 2. 0 and pi by 2, right? Next, for 1 and 0, when s is 1, t is 0. When s is 1, where is the definition? When s is 1, t is 0, what do you have? You have pi by 2 here, and here because s is 1, this quantity is 0. So you have pi by 2 and 0 here. So it is pi by 2 and 0 here. And for the last entry, 1 and 1, let's see what do we have here. When you substitute 1 here, so this quantity 1 minus 1, that would give you 0, and here also 1 minus 1 would give you 0. So we have 0 comma 0 here as the image for the point 1 and 1. So these are the points. Let's draw them on the M1 and M2 axis. This is your origin. So one point is 0 pi by 2. So first entry is 0, another is pi by 2 somewhere here, right? Another is 0 pi by 2 somewhere here. And the third entry is again pi by 2 and 0, right? So this is this one, and we have 0 and 0. So you have 3 points out of those 4 corner points. So let's join all these points. When we join these points, we obtain a triangle here, right? This is the triangle, and you know the sides and the distances here. This is how much, what is the length here? It is pi by 2. What is the height here? That is pi by 2. And you know how to calculate the area of this one. The area would be half into base into height, right? So what is the value of base here? That is pi by 2. What is the value of height? That is pi by 2, and we will be multiplying it by 1 by 2. So your answer would be pi square by 8. So that is again option C. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.